some string methods. So we just saw some functions a moment ago. We saw input, stir, len, char, ord, and eval. Methods are very similar to functions. They're just invoked slightly differently. So for example, if I have s equals abc and I can print the len of s, len is a function and we're very used to functions. But I can also call methods where you, instead of saying f of s, I say s dot f or s dot m for method. For example, I can say s dot upper, and that will convert this to uppercase. When you invoke a function in this way, it's not called a function, it's called a method. So upper is a method, and otherwise methods and functions, for our purposes, are pretty much the same. All right, so what are the some string methods? There are other string methods. We're just going to look at some of them, the ones that we expect you to know. The first one tells you the composition of the string. Is alnum, is alpha, is digit. So here, if I have a string ABC, I can print s dot is alpha, and we see it's true because it's only full of alphabetics. But if I say ABC space D and run this, it's false because of that space, which is not alphabetic. I could say ABC exclamation, still false. So these tests are testing whether or not this string is made up of different kinds of characters. Alna means alphanumeric, so that would be letters or digits. Alpha is only letters, digits only digits, lower is lowercase letters. Space would mean spaces, new lines, tabs, more spaces. I say is space, and sure enough, that's true. And upper is uppercase letters. So let's copy this and go here, paste, and run it and see what's happening here is it's actually creating an interesting table. You can look at the code on your own time to convince yourself it's creating this table, but for every string inside this collection of strings, which we split on the commas, so for ABCD, which is there, ABCD at mixed case, all lowercase, AB12, and so on, and this empty string here isn't empty at all, it's a series of spaces. We go ahead and for each string, we call each of the different methods, and we call P, which is just a function we wrote, which will just print true or false with some nice formatting. And we get this table right here, which is a very handy table to help you understand how these different methods work. So ABCD is alphanumeric, it is alphabetic, it's not a digit, it is all uppercase. Most of this table I think is very straightforward. Maybe the only ones that are surprising is this one right here. AB question exclamation is in fact uppercase, which means is upper. You can be is upper while not being is alpha, which is to say is alpha says are all the characters alphabetic, whereas is upper says of the characters that are alphabetic, are they all uppercase, which is certainly true here. Is lower gives us an equally surprising result right here, where it's not alphabetic because of the digits, but in fact the ones that are alphabetic are lowercase. So, pardon me. So then we'll come back here, and there are these functions here are straightforward. Well, at least lower and upper and strip are replaced, maybe just a little less so. Lower and upper convert a string to lowercase or to uppercase. Strip removes or strips the white space, the leading and the trailing white space. The white space inside the string is left alone. So if we go ahead and select this and go here and copy and paste and run, now we'll see this is nice, yes. This came out all in lowercase because of the lower. This one came out in uppercase because of the upper. Notice uppercase leaves non-letters alone, doesn't try to convert them. Strip, sure enough, stripped away the leading and the trailing white space, but the white space in between, such as this one, was left alone as advertised. Replace. So replace takes a word, well, not a word. Python doesn't know about words. It takes a string and another string. It says inside this string, find every occurrence of the first string and replace it with the second string. So this is nice, really nice, becomes this is sweet, really sweet, as we see right here. Now what you can do is you can say, and this is the number of times to do that. Only once. So now the first nice becomes sweet because of this substitution, but the second nice does not because we said stop at 1. Okay, so one last thing you can see is you can replace a string such as so followed by a space with the empty string. So followed by a space and so followed by a space. Both are replaced by the empty string, leaving this is fun, pardon me, this is fun as the result of this replace. So the point of this right here is there is no delete or remove operation for strings, but you can replace a substring with the empty string, which seems to have the same effect. Of course, we don't modify s because strings are immutable. So it's the way to create a new string which effectively deletes or replaces some portion with the empty string. Which finally, now there's the methods that go ahead and search if one string is inside another string. And there's different ways we can do that. So there, what we can do is we can count how many times does is occur in this string. Well, there's is, and is 3 times. Python doesn't know or care that these happen to be inside words or a complete word unto itself. It's just looking for this pattern inside this string and counting that. It's case sensitive, so capital I does not match. So this would be 2 times. You can also ask if a string starts with a specific string. Dogs and cats does start with do, doesn't start with don't. You can equally ask if it ends with a certain string. Find is a little more interesting. The way find works is you have a string and you ask, does it contain this string? So it seems like you could ask, there's several ways we've seen that you can ask that. This is one way. But find gives you more information than if and is in the string. It tells you where in the string. So it returns 5 because it indexed 0, 1, 2, 3, 4, 5. This A, which is the starting point of this and, is at index 5. So this call returns 5. Now, what if I try to find an or inside this string? There is no or. So the way find tells you there is no or is by returning -1. What's awkward is in Python, -1 is a perfectly valid index because Python allows negative indexes. Nonetheless, find returns -1 to mean I did not find it. Index works just the same as find. So index of and will return 5. It's the same, except unfortunately, index, when you try to find something that's not in the string, instead of returning -1, it actually crashes. So when we take this code here and we run it, we see that we actually crashed, substring not found. And if we run this entire code, we get that same crash. Since index works the same as find, only it crashes on failure instead of not finding, rather than returning -1, you just shouldn't use index. You should never use index. Use find. Unfortunately, as we'll learn when we do 1D lists, there is no equivalent of find over lists, which is unfortunate, but there is an equivalent of index. So we will be using index in the future, but save that for lists. And for now, over strings, just use find. And with that, we've reached the end of the string methods that you are responsible for.